In this video, what I'm going to show you how to do is how to download a library that's not in the library manager and use that. But it also is going to demonstrate this like neat trick where you can make a switch without actually a physical something. So this is something called it's capacitive sensing, and this wire right here acts as an antenna. And when I touch it, we'll see the onboard LED turn on. So grab it, the LED comes on, I let go, it turns off, right? And if you get this sensitive enough, you could do this underneath paper. You know, you could make like a switch that's like a big piece of foil or something like that. Here, it's just whenever I touch the end of the wire here and grip it. So it's one neat trick that you can do with the microcontroller. As you can see right here, you need a mess of resistors in order to make this work. I'll walk you through it real quick. So the library itself is called Capacitive Sensor. It was written by this guy, Paul Stoffrigen. He just updated a few months ago a version of this for the kind of board that we're using. But it's something that isn't included necessarily in the Arduino library manager. It's maintained and operated by somebody else independently. That's not to say that they won't support it in their system, but sometimes like this change is recent enough that it hasn't necessarily made it into the library manager itself. So we want to download it directly from GitHub. So if you stumble across a library that you want to use, it's not part of the it's not in the library manager itself. If you find like a GitHub page, for example, like this, what you can do is you can go to the big green code button and we'll say download zip. I'll do that, and yes, I want to download this, and it popped it into a folder for me right here. It unzipped it for me automatically. But it created this file right here called capacitive sensor -master. And so this -master thing is actually part of GitHub nomenclature. It's useless to us. And in fact, we'll make sure that your library won't actually work. So what I'm going to do is I'm going to rename this to just capacitive sensor. And if I look inside of here, we'll see there's a couple files. There's one called capacitive sensor CPP. This is actually the code of the library itself, so you can look inside of there if you're curious. There's this other one, capacitive sensor.h. This is the header file, so this is all the definitions. There's keywords, so these are the things that get highlighted in the Arduino IDE. There's some documentation, and then there's examples, right? This one just has one example, not even going to use it. We're gonna use our own. So to install this, what we're going to want to do is navigate to that place in our computer on a Mac. It's inside of your Documents Arduino folder. And so this is where your sketches get saved. You should see a bunch of things in there. You'll also see another folder in there called Libraries. On Windows, this would be in your Documents I think it's Documents and Files or something like that. That's where the Arduino library lives, or the Arduino files live. But inside of there, you'll see a folder called Libraries. If you open that up, you'll see any libraries that you've downloaded previously. These are two that I downloaded earlier. And what I'm going to do is I'm just going to copy this into the software, right? So next time I open up the Arduino IDE and well, let me just quit this. So next time I open, so if anything that I pop in there that's not that isn't going to show up automatically if the IDE is open. So I want to close it and then open it back up. And when I do, I will see this library and the examples in the file drop-down menu, just like I would with anything that was pre-installed or installed through the library manager itself, right? So here, if I go under File, Examples, you'll see down here, example from custom library. Hey, I've got a custom library now. That's pretty great. Capacitive sensor sketch. Cool. So this is installed. Great. What I'm going to do is I am going to, this is my, my sketch here. I'm going to walk through the code, and then I'll walk you through the circuit, and I'll show you what's going on. So the way that this works is the microcontroller has constantly sends out a pulse. So it turns one pin high really briefly, and then on a second pin that's connected to through a series of resistors, it measures to see how long it takes for the charge to actually be read. So, and what we're doing is if our body is interrupting this or touching this, and this antenna right here, what happens is our body absorbs part of that charge, where we basically act like a giant capacitor or battery. And we store that and then we discharge it. But it, depending on how a bunch of different factors, how large we are, how humid it is, how sweaty our palms are, this value will change. So we are basically measuring how long it takes to read a pin between turning another one on and off. So in this case, so you need to use 2 pins for this. And in this case, I'm using pins 4 and 2. And pin 4 is the discharge pin, and pin 2 is the input pin. So pin 2 is the one that actually measures to see if I'm touching this or not. So here we create an instance of the library. We say capacitive sensor, and then we give it a name, and then we say capacitive sensor, and then the arguments are what pins. And the first pin is the sender, and the second pin is the receiver. So pin 4 sender, pin 2 receiver. In my setup, I start serial so I can see what the values are. I configure the pin mode for my LED. The built-in LED is an output. You could use this for a servo motor. You could use this for an RGB LED. You could use it for any other kind of actuator that you wanted. I'm keeping it simple here because this circuit's messy enough as is. And then inside of my loop, I've got a variable here that stores the value from the sensor. So it's of type long because it could be a very large number, hopefully not. And what this does is it measures the amount of time that it takes for this sensor to actually discharge. So the way that we do this is we say val equals capsense capacitive sensor, and then the number of samples that we want to take. So how many times do we actually read this pin while we're doing this? So I've got this down as 30. You can decrease this or increase this and see what happens to the sensitivity. This is actually what comes out of the box, and it works. And then, so what happens here is the value, when there's nothing connected or nothing near it or touching it, it should be near or close to 0. And then as you touch it, you'll see that it'll go up. From testing this previously, I noticed that it was somewhere in my apartment this evening, somewhere around like 200 if I'm really touching it hard. I put the threshold kind of low. I could change this to whatever. You just need to sort of experiment with it. So I'm saying if the value is greater than 30, turn the built-in LED on. If it's less, turn it off. And then I print the information to the serial monitor just so I can see the values. I've already uploaded the code here, so I'm going to open up the serial monitor so you can see the values as they scroll past. So right now it's a value of 0, and if I touch it, you can see it gets up to like 300. That's pretty great. And then I let go, and pretty quick, and almost instantly snaps back down to 0. So you can see as I touch this, and you can get different values. Sometimes I'm touching it, I'm really clenching it, and other times it's a little bit looser, right? So you could figure out some sort of threshold for that. You could make a giant antenna out of this if you had like a big piece of metal, aluminum foil again. You could cover a large area and have somebody just touch that. It would totally work. Now, the other thing that you'll notice here is this big mess of resistors. The way that this works and what it expects is actually a really large resistor bridging the send pin and the receive pin. And normally what you'd do is you'd get something like a 1 mega ohm resistor, and then this would become super sensitive, and you could measure this touch probably like through a 1/4 inch of drywall at that point in time. Since we don't have a resistor that large, what I've done is I've taken all of these 10 kilo ohm resistors that I have, and I put them in series with one another. So I've essentially built up a 50 kilo ohm resistor. So you can see it goes in this illustration here, it goes from pin 4 to this, from here to here, here to here, here to here, and then here it goes back into pin 2, and off of pin 2 in parallel I also have this antenna. So a little bit messy, but it works, right? And if you have access to, I'm doing this just with the things that we have inside of our kits, but if you have access to a larger resistor, so maybe like 100 kilo ohm, a 500 kilo ohm, a 1 mega ohm, then you'll increase the sensitivity of this. So this is, you could have multiple instances of this in the library page. Paul's got a video of like 3 little bits of copper that are being touched like this and played like a piano almost. You could think of a whole bunch of really interesting sort of like ways of applying this. And they work great for just sort of like on-off, look for a threshold. And if it matches that threshold, then something's present. And if not, something's not present. Again, this is also a way to show like how you would install a custom library, one that's not part of the library manager. It's good stuff. So try it out if you're inclined, and let's see how it works for you.